easiest way to deal with end behavior when we're doing this is to go ahead and type it into my calculator. Because visual is a very much easier way to make this be something's kind of simple to work with. So I hit this graph, and a lot of times what I'll do is I'll even make myself a quick sketch. It doesn't have to be perfect. It doesn't have to be like so accurate that I have to go break out the table. But here's how this is going to work. So when I'm trying to discuss what's called end behavior, okay, f of x is my way of saying y. You're like, well, why don't you just say y then? Because f of x is function notation, and this is what we're doing. We're discussing functions. So f of x is my y values. So for right now, I'm just going to write a couple of those down with an arrow afterwards. I'm not going to write anything in there yet. It's kind of a blank I'm going to fill in. So if you want to put a blank there, even you could. But the right side of this is always going to be the same thing. Because when we're describing end behavior, we're describing what's happening visually from left to right in my picture. So when I put this part, here's what I'm actually saying in English. As x goes to the left, because if you think about the x's, if you're going to the left, where are you heading towards? You're heading towards negative infinity. So that will always say x approaches negative infinity, or x arrow negative infinity. The one on the bottom will always be positive infinity. So as I'm going, oh, positive infinity is to the right. Okay? This part never changes. I'm always going to have one part where x is going left, one's going right, sort of like I'm doing when I do domain. So you're like, okay, so how do I figure out this part then? Well, let's look at what's happening. As x is going to the left, okay, as this graph's going this way, which way is y going? Down, okay, because y goes up and down. So as I go left, y is going down. Our way of writing down with this is negative infinity. Okay? When I'm on the y-axis, positive infinity as I go up because the numbers get bigger. Negative infinity as I go down because the numbers get smaller. Okay? X-axis, we were just talking about that a second ago. With my x-axis, as I go right, I'm heading to positive infinity. As I go left, I'm heading to negative infinity. So we're just kind of giving some words or some symbols to the directions that we're going. And then I look on the other side. I'm like, okay, so as I'm going to the right, what's happening to y? It's going down. You're like, check all that out. So here's what we just said, actually. We just said y goes down as x goes left. Yes, it does. Y goes down as x goes right. Yes, it does. This is what end behavior is. Okay. Now, I want to do another one of these because there'll be plenty others for you to be able to play with here too. But that's basically its calculator. Now, technically, there is a way for you to be able to do these without looking at the picture. But I figured doing all the little tricks with odds and evens and stuff wasn't going to be something that was going to be real helpful for some of you. Ooh, that's kind of funky. So, we're just going to kind of keep... And again, your picture doesn't need to be perfect by any means. Just kind of... We're really paying most attention to what's going on at the end. So I look and I'm like, okay, I got this. I'm going to write 2f of x's with blanks because that's my y's. That's the part I got to figure out. But my x's Okay, again, one's always going to negative, one's always going to positive. Because again, I need to know what's going on as I go to the left. And I need to know what's going on as I go to the right. And maybe once you do a few of these, you don't have to write left, right, and up and down anymore. It just kind of becomes a little more natural for you. But here's why, again, I like to literally graph it myself. So, as x is going to the left, so as I keep going to the left here towards the arrow, we're going down, which is, how do I write that? Negative infinity. Because my y value is going down. What about, though, as I head towards the arrow that's going right? I'm going up, or I'm heading towards positive infinity. Okay? And that's it. That's end behavior on how these work. But again, and I've also got the examples written over on the board where I literally put like A's and B's to kind of let you see what's going on as we look at each direction so we can see how that works. Okay. So calculator, and then just kind of run with our infinities, seeing how that works. And then this other parts, I just thought we could use a little extra review time just to go over some of the language that was gone over in the lesson Friday. So we're going to take a peek at a couple of these too. Okay, write in standard form, biggest exponent to least, and then name the polynomial by degree and number of terms. And we've got this right on the top of your note sheet from Friday, okay, where we've gotten into all the funky names, and then we've got monomial and binomial and trinomial and all that stuff. So we'll take a peek at a couple of these. So like let's say when we were looking at 6. Standard form, find the biggest exponent and work your way down. Okay, so there's my standard form. I can check that off my list. Name by degree. The degree is always determined by the biggest exponent that you have. So this is a cubic. Now just to kind of get them all in one spot. So for instance, if I have 1, it's linear because it would just draw a line. Okay. If I have 2, that's quadratic. That's going to be a parabola. We just got done with the whole unit of those. And then 3 is cubic. And yes, there are ones above that, but since mainly everything we do in here is going to be one of those 3, those are the main 3 that I'm going to list right here. So number 6 is a cubic. And then my number of terms, and you've had some experience with these before. Okay, 1 is a monomial. Mono means 1. Uh-oh. 2 is a binomial. 3 is a trinomial. Now, again, technically there are some names beyond this, but typically once we hit 4 plus, we just call it a polynomial. Because now you're just getting to a point where there's just too many things to be keeping track of. Okay, so when we name it by degree, linear, quadratic, cubic. When we name it by number of terms, monomial, binomial, trinomial, polynomial, just so we have a common language that we're using. So this particular one would be a cubic polynomial.
Is it okay if we have it separated though? Like degree, like we have it wrote out in the name?
Oh, yeah. Yeah, that's a-okay. So let's peek at one more here. We'll peek at 9 because I see it's got some different stuff working here. Now 9's cool in that I don't need to rewrite anything. That's already in standard form. X squared is bigger than just the -1. Our constant term always goes at the end. Okay, so how am I going to name this one? Okay, a quadratic binomial. Because anybody that could come up, even if they couldn't see this part, if you said, hi, the thing I'm thinking of is a quadratic binomial, they'd know it's something squared and that there's only two terms. Wouldn't tell them a whole lot, but it'd give them a little more information than they had. Okay, so that's how we deal with this middle part. Again, nothing that's too terribly awful. So you're like, okay, well, it's better than the first part. What else you got here? Okay. Simplify the expression. In other words, get it into standard form. Be careful. Okay? Again, these are not multiplying problems. The only part where you may have to mess with something is if there's a minus in the middle somewhere. Because that minus means all the signs on the terms after is going to change. So I leave alone everything that's in the first set of parentheses, the first quantity, because there's no symbol in front, no number, anything like that. And then I just change the signs on all of them after. Now, I'm not done just by doing that. I still need to combine like terms, and I need to put it in order from highest degree to least. So I look, and I'm like, okay, 3 is the biggest one. So any place that I see next to the third, I got 7 of those, because remember, there's a 1 here, even though I don't see it. And then I look for my squareds and watch the signs in front. -5 plus 7 is 2. I don't see any plain x's, but then I see those guys. 1 minus 3 is -2, and we're just simplifying. You do not have to label them with, cubic trinomial or anything like that. Just go ahead and get those written in, and you're good to go. So up here, that's all I'm dealing with. If it's plus, just literally put like terms together. And if it's minus, I got to distribute that negative on through. Okay, thank you. So, just a little like terming up there, and then the bottom, I had to do it, especially after some things going with the test. I want to make sure we've got this part. So when we're up here on 18, and then we're going to do 21 together too, you have a choice if it's a 2 by 2 of foiling, or you can use the box for everything. I don't care. Okay? I'd really highly suggest against trying to distribute on 21 and 22, just because there's a whole lot of places that things can go bad. So if you like doing the thing with the lines, you can. I still am going to push towards getting these things situated, where all I'm going to do is write along the edges of the box what's going on. And then I'm multiplying what's inside. So 3v times v would be 3v squared. Since I'm multiplying, I add my exponents. 3 times -7 is -21v. -7 times v is -7v. And negative times negative, bless you, is positive. But don't just leave them in the box. Okay, we need to actually combine like terms and get it into standard form. So I start with my squared. I'm just combining now, so no more messing with the variables. -7 minus 21 is -28, still just v. And my constant term at the end. Okay, so you see why it doesn't work to just dink, dink, and call it done. I'll get the first term, I'll get the last term, but I won't get the term in the middle, which isn't going to help me out very much. But 21, like I said, I'm really not going to speak much to other options, because this is so nice in organizing your like terms and making sure you're not forgetting anything, that I really, to be perfectly honest, couldn't understand why you wouldn't use this. So again, it's all about multiplying the edges, and I like putting my one exponent on there just so I don't forget about it. And again, it's just taking what's on the edges. 8 times 5 is 40. 1 plus 2 would be 40 into the third. Plus 48. 1 and 1 is 2. Minus 48n. If you wanted to put the 1 on there, you could. And I'm just working my way through. And like I said, the nice thing with this is that if I start in the upper left-hand corner, all my like terms are, going to be lined up for me. And again, I'm just watching the signs in front. Don't try to get cute and start thinking. I make it like end of the fourth or something. Again, here, careful, 12 minus 48. And then the minus 12 is on its lonesome here at the end. Okay? So again, try some of these out. There's a key up front. If you check something, if you're still having a question, let's chat, let's get that set. And tomorrow we'll be moving forward to add, subtracting, and multiplying with some of these things. So just make sure you've got yourself good and ready for that.
So okay, so just for the boxes, so you
Sure.
box it and then you just can add the like terms.
Yes. Yes, it's